All right, well, thank you for being here today. This is a continuation of the track that we just did on the last session. The first one, an introduction. This one's a little more 201, maybe not a 401 session, but more advanced information than what we gave into the last presentation. And I'm Joe Shonk. This is Steve Greenberg. And
does he sound muffled? He always sounds muffled. It seems like your mic's underneath.
He always sounds muffled.
Hold on a second. How come I always have to dress you?
Oh, thanks.
What is it?
And then we've got Hal Lang over here. It's our V-Hobbit. So,
Who just won the iPad, by the way.
Yeah, I'm loving BriForum. I just won.
You won the iPad?
Check, check.
I did.
Well, Barry wasn't pranking you?
No, he wasn't.
Yeah,
I actually
okay.
won.
Okay.
So this is more advanced. First thing, talk about, storage is boring. So, to liven things up a little bit, I thought I'd start off with a joke. And so, 3 ducks got arrested, get put up in front of a
I don't think
judge.
you can tell that joke here,
Why
Joe.
not?
I don't think so.
Okay. A bear walks into a bar and
Bear?
Can
You know this
either?
one?
What can
no,
I do?
No. Tell us something more from your experience than that.
All righty.
No ranting. Go back to the jokes.
No, go back to the
All
rant.
right. I want to point out something here. There's something wrong with this particular solution here. I'm hoping somebody can help me identify what I think is wrong with this solution. I know it's an EVA 8000, and if you say that, you're correct, but that's not what I'm looking for.
I put 2 away. Thank you. I'll pull them out.
I'm sorry.
Number of storage arrays or storage disk, the number of servers in here.
Number of arrays and number of controllers.
So you're saying the number of arrays versus the number of controllers is out of sync? I'm going to put another one up here. You might recognize this, right? It's actually a NetApp 3000 series. So we got a device here that's capable. You want to try? No.
Well, that's an interesting point. Yeah. Yeah.
What's wrong with this picture? Throughput? It could be an issue.
These are all good points. Not what he's looking for, but all good points.
So fuzzy,
They're not win a copy of Storage Area Networks for Dummies
Let me go
good,
back to
but
this
they're
one
good
here.
answers.
So is it highly available? Is that the highly available?
All right. Well, over here.
Over here. All
What?
the eggs in one basket.
Yeah, that's a good way to
What?
put it.
All the eggs in one basket. That's
Okay. Close, yes.
Okay,
That's
getting
very
better.
close. And it's high availability, right? We got 2 controllers, we got 2 switches, we've got storage in that rack of what are off of each of the controllers. Do you think this is highly available? Or this one here, you got 2 controllers in the middle serving all that storage. Is that highly available?
His mic is rubbing. I don't know what to do. Clip it low.
What? The obvious answer is no, because I'm ranting about it.
Sorry, your thing's moving around, so I don't know what we have to do.
Make sure you get the hair.
Fine. So my issue with this is we're putting all the redundancy in a small number of racks, especially the previous one. We've got all our controllers in the same rack, we've got our switches in the same rack, and in the previous one, all the storage was in the same rack, right? And people come to us, oh, no, that's highly redundant. We got multiple power sources going into that rack. It's not going to go down. But, we've seen things like this happen before, where the data center or part of the data center burns down. Things like, pipes break. So again, are we talking about highly available storage? Or are we...
I also want to add that these aren't hypothetical. We didn't have actual pictures on these particular slides, but we do have on others. We had actual data center fire at one customer, and we had the Zen Garden example, right?
Yeah. So
I worked at a place where they actually had a water feature in the data center inadvertently by an air conditioning pipe breaking and just pouring down on racks. Right? And these do happen very, very frequently.
go back to this one. We had a customer that came to us. They had a fire in Mexico. The data center burnt down. And they shipped storage arrays, say, hey, is there any way you can recover the data off of this? And the box is completely charred. And fortunate for them, they were able to pull the drive out of the chassis, put it into a new chassis, and actually recover the data off of it. And the only reason that data was saved is they had placed that in the corner of the data center. Well, with the rest of the data center got burned, it kind of extinguished by the time it got to this small little corner over here. So the damage wasn't as great as the rest of the data center. But on that storage array, they had the line
That's
of
what I was
business
saying. Where's the other
application
one on here, do you
for
know?
that location. So all the accounting information was on there. The workflow, the business workflow applications were on there.
Do you have the other mic? It's moving around. It's annoying. You can't hear it, but I have to fix this.
Right.
It's annoying me.
Annoying you?
Is it annoying you? Okay.
This is the house mic. This is the.
Yeah, try it now.
I don't know how you're hearing the video mic.
It's, I don't know.
It was on the house mic, it
I don't
was
know.
on my video mic.
Okay.
Okay. Good story, though. Keep going.
And the other thing, they had no backup. So if they had lost this data, they were screwed, right? We have another customer. They decided they wanted to build a nice little Zen garden, rocks, waterfalls, and stuff, right next to the data center.
So relaxing.
They turn on the waterfall stuff, everything's nice. Next thing they know, the data center's flooded. And you don't necessarily need to have a disaster in order to put your data at risk. We had another customer that there used to be a door here. This was the only door into the data center. So we ended up making a door to get into the data center. Come the next day, that door was gone. But, you know, lucky
Talk
for
about
us,
remote
they built a
access.
door on the other side of the data center. And you can see there's a big mound of dirt there, and there's a big mound of dirt there because there's a big hole in front of the freaking door. And what you can't really see in this picture is a bunch of metal shard pipes coming out from the bottom of this. So if you slip and fall in that pit, you would be,
Who
yeah.
played Pitfall for the Atari 2600?
This is Pitfall in real life.
Yeah. Well, I'll put it up there. So, you know, if you were able to make the leap across into the data center, you would finally get in here, right? So this is a live production data center with racks and stuff running and construction going on all around it. And here's the storage device. Again, we see two controllers. They're actually the data core controllers in this case. Two controllers and two XIO units in the same rack on top of each other. If something happened to this rack in the middle of construction, they're down. And just to kind of show that we didn't make this up and got this off of Google, you had to have a hard hat to even get into the data center. If you didn't have a hard hat, you got yelled at. But, you know,
So you had to have the hard hat, but you could make your own door?
you know, during the
figure.
construction, they put in
Teamsters are
plastic around the cases. This is my favorite one. They put a plastic bag on top of the rack. If you lift the plastic bag up, you get hit with a heat wave. You know, a couple servers, you know, had some heat issues during that time. You know, it just moving stuff around, stuff like that. They were fortunate when they were all said and done. They only lost a couple servers in the process. So with all the heat, the dust, the drywall, they were lucky that, you know, before they actually lit everything up, they took all the servers outside, aired them all out. It was freaking hilarious. But so this was the session abstract, I guess, that was submitted for this. You want to?
Yeah, we're going to talk about architectures and designs. Again, this is more advanced, so we're going to take some of the basic concepts and build them in how you actually put together a design. You hearing me okay? Designing a solution that works based on experience, some things that we know should and shouldn't be done. And my favorite slide is the lies of storage vendors, because we've had to live this, and so we've got this down to like a few points. Joe's going to take you through actually measuring IOPS and what you can learn from them and some tricks around that. And then we've got data on sizing and storage requirements. And then this whole emerging area of using RAM and SSD to kind of cache, tier, optimize your storage is a topic as well. Why did we do this session, Joe?
Because last year we had a kind of an intro session, and when I came to BriForum, I actually had a presentation all put together. Then I looked at the abstract after and realized that this session was just way too advanced for the session. So we spent the entire night redoing the entire session.
Not to mention it was over 100
Yeah,
The what?
that too.
Over 100 slides.
Sorry. So we did that presentation and we still only got halfway through the presentation. So we figured, all right, let's take that presentation, let's redo bits and pieces of it, split it into two and do more of a basic and more of a more advanced version of this. So for this one, we kind of expect you to know a little bit what block level file systems, file protocols, different types of, how storage is presented to a
And it looks like
hypervisor.
most of you, I think, were in the first session. So these were basically all the terms and concepts that are prerequisites for what we're going to talk about.
Let's talk a little bit about architecture and design, maybe a little bit different than your conventional storage architecture and design presentation, talking about fiber channel, InfiniBand, when and when not to use them. But in our case, we do a lot of virtualization. We kind of got thrown into the storage arena, not by chance, but because of necessity. In order for our project to evolve and move forward, we had to actually learn and even implement storage solutions for customers in order for our projects to
And I'm also, it's interesting to note, and I'm proud to say that a number of those solutions that we architected for VDI became replacements for the organization's overall storage strategy. So they'd have these big, honking, expensive, three-letter name companies. And yeah, can you help that out? Thank you. And we'd come in and do these specialized solutions for VDI, and they end up throwing out the big vendor and using what we did for wider deployments. It'd be nice if we can nail this down.
So explain why everything uses storage.
Okay.
The reason we got into this to begin with was because our projects were destined to fail on the current storage. And
Exactly.
there was no other way around it. We had to either fix it or rebuild it to get things to work properly for the customer to have what they wanted.
Right. So the first thing you need to know when you're going to do an architecture and design is what you should gather. But even before you gather anything, please don't buy anything. I can't tell you how many meetings we've been into where a client or a prospect comes in and goes, hey, we're going to do this VDI project and we're all set to go. We just bought $1 million worth of EMC. We're like, why? What's your project? Jerry knows. It's like, well, because we're going to do this project. Well, what is the project? Well, you have to figure it out. We just know we're going to be virtual. Well, it's like, you don't even know what you need yet. And,
We need a lot of storage.
Right.
There's going to be a lot of VMs. We need a lot
So
of storage.
start by don't buying or telling your client or your company, don't buy anything, let's research this. It seems so obvious, but so many times even our client can't tell us the business requirements. So you have to understand what's trying to be accomplished at the high level. What does the organization want to accomplish? In our practice, a lot of our work is actually covert. We go into an organization, they tell us they want this. We go, okay, well, can I spend a day in your call center or your manufacturing, whatever? And we find out completely different things. It's so often the IT guys don't actually know what the business does. So it's simple and obvious, but it's not.
It's not only that they don't know, they don't really care. Right? They
Well,
keep their
let's
systems
talk
up.
more into the...
They keep their systems up and running. They don't really care what they're being used for, so they're not going to really care what the business side is really, what their requirements really are.
Exactly.
You have to get outside of the IT realm to be able to get the actual requirements, so your project can be successful.
So after these sort of intangibles, then you get into gathering what the users and the application workloads say that they need in terms of capacity and performance.
If you're doing an imaging system, you're going to need that data, you're going to need high performance in the interim while all that data is being scanned in. But long term, it can sit on really slow storage.
Great example.
You need more capacity, but you need less performance out of that. But you're not going to know that until you actually talk to the business owner of that project and see, okay, what is it you're scanning? How much data does it take? You need to go out and actually investigate what's going to consume the data and what kind of requirements are behind that data.
And what will happen is
availability too.
you'll talk to the end user and they'll say, well, it must be super performant. I'm doing thousands of images, and it turns out they look at 3 an hour, and the rest can be on slow-moving storage.
Thousands of images are when they're looking at the menu for lunch.
Yeah, that too.
Is it a SQL server that needs to be available 24/7?
Right.
Or is it some archival system that can be down for a couple hours?
Exactly. And then you take those requirements, availability, capacity, and performance, and you rationalize them, and then rinse and repeat. And by that I mean when you take your experience and interpret, are these images online? Are they archival? And you have to do that. You have to insert yourself in. And after you've done that, please still don't buy anything yet, because you have a lot of other decision points to make. The biggest one being, Are you looking at a big honking strategy of storage where one frame or one solution is going to serve up every workload? Or are you looking at point solutions? Both approaches are valid and hybrids, and you want to think about that. This gets into the lives of the storage vendors. The big frame guys want to tell you, buy our array and we can service every workload in your environment, and we find plenty that break it.
I mean, for me, that's a really hot topic. I mean, when you go into a data center, you don't see, one or two servers controlling everything in your environment. You got your blade servers for this type of work, you got your one use for this type, Dell over here, HP, HPUX. You have a different flavor for all of the different workloads you have. Why don't you do the same for your storage?
Yeah, it's
Why
like
don't you look at it as this storage needs to be able to support this type of work, this storage needs to be able to support this type. So instead of buying this massive EMC that has all these petabytes of data, but you suffered in performance and you need it on these workloads. So why would you do that?
so you go to
a very hot topic.
So let's say like you go to a community pool, right? Do you build a kiddie pool and a big pool? Or do you have one big pool and let the kids pee in the big pool too?
I vote for kiddie pool.
So we build this, point solution.
I'll just have the blue guy into the water.
Alrighty.
All right, after you've gathered your data, you have tasks now. Your architecture, there's some certain steps that we think that we've learned that are very practical about what you need to do next.
So what kind of performance capacity do you need? You're going to whiteboard with your customers and decide, hey, what kind of pools am I going to build? What kind of performance is going to be around that pool? What do I need? What do I have now? And this was kind of an example, a session we did with one customer. It's like, okay, I've got these volumes. How am I going to carve up the pool of storage that I have? And how am I going to present that? What do I need to present? What am I going to migrate over? Second, availability and performance requirements. We've talked a little bit in the beginning section about high availability. We didn't talk so much about data protection. And the two different strategies. You can be highly available, but your data can still be at risk. You never want to underestimate your end users, because they can really screw things up.
This is real. This is a customer machine. This is not off the internet.
So what happened here, one of our customers, and one of the employees, they got a laptop, accidentally spilled water on it. Freaking out, knowing that water and electronics don't mix, they threw it in the oven for 10 minutes. It actually still works.
The really scary thing is the organization is a higher ed institution teaching medical professionals.
So, things like CDP, snapshot, replication.
Yeah. Luckily, it's dental, so it's not as bad.
What is your backup strategy? Does it look like this? Or do you have some really cool storage tech with a big robot? That one. It's got the big robotic arm and hundreds of tapes, and then that robot goes and picks the tapes out and sticks it in the.
Joe likes the robot.
I like robots.
One thing about that too is just to underscore in a practical thing. It's one of the things you kind of learn just by experience. Is high availability is not data protection. So you have to have your availability and then where your copies of your data are stored, and kind of separate those concepts. Because highly available doesn't mean you have snapshots or copies or tape or online disk.
You need to build a migration strategy. If you have existing data and you're buying a new platform, how are you going to move the data over? What is your migration strategy? Are you going to depend on a new appliance, connect into the old one, and replicate that data over? Are you going to do replication on the front end? Depend on the actual application, like Exchange Server to do replicated stores. How are you going to do robocopy? Are you going to do proxy volumes and volume replacements? You need to develop a strategy for that. What's the next one?
Do we talk about the points or go to that picture?
Next.
Hit it?
Yeah. All right. Once you gather some of that stuff, you can start planning, start designing what you think the initial architecture is going to look like. You're going to need fiber channel, iSCSI, direct attach storage. Are you going to do PVS? This is actually a real example of, talking about PVS architecture. I don't know if you can see the little box there, but yeah, we actually had a discussion drinking beer one night and playing crickets. And it turned into a PVS discussion. So yeah, it kind of started off there, and at some point it ends up to something a little more uh, more logical on a whiteboard, and you start hashing this stuff out and understanding what kind of architecture you're going to use.
Before you go back there for a second, I just want to point out what's cool about this is, Joe, these are all real whiteboard pictures from meetings. So you can see that like you've done this architecture rough, and then you start to put it out on the board. You got all the redundancy, you got multiple controllers, you got the ISLs.
You ever want to document a whiteboard? Use your phone, right?
Yeah.
Why try to write it down?
Yeah.
Take a picture.
Yeah.
Front end versus back end. So when you're building in some storage solution, you have front end clients and you have back end. So we do a lot of data core stuff with XIO. So the underlying storage itself, the XIO ice blades, actually are considered back end storage. And so there's a back end network that gets aggregated up into the data core controllers. And then you also have your front end servers, your hosts, that are actually going to consume that storage. So we also have to design a front end network, a back end network as well.
And that's where like these concepts in the first session come into play, because is that going to be iSCSI, fiber channel? How do you attach to the devices? You might want to do fiber channel in the back end to the storage arrays, iSCSI up front, understanding which part is going to be NAS. This is where you all have to design this at this stage in it.
Do you want your data in one place or in multiple places? There seems to be some resistance when we talk to customers about synchronous replication, having your data in two different places on two different pools of disks. And the pushback is, I got to pay twice as much for storage, right? But then you think about it, you just think your data is in one spot only. If you don't synchronize it, you don't try to protect that data. Even if you want high availability, if that rack goes down and that server dies, blue screens, whatever, things happen. Is your data still available? Is it going to be available from the other controller?
Don't forget the room is called a data center.
Yeah, it's called a data center.
Not a server center.
Not a service center, not a storage
And that's one of
center.
There's a practical point there too, is as you did with the visual images early on, is even if you're going to be confined to the data center, think of it as east and west or south and north, and create separations, even if it's 2 racks, make those separations so the redundancy and the independence is there in your design. We've actually done customers where they were building a second data center and it wasn't ready yet. We built an entire storage infrastructure that was synchronously mirrored, and it was designed so you literally could just pick up rack 2 and move it to the other side of the campus when it was ready.
Yeah, so single site, multi-site. Obviously, multi-site can be better, so it has lots of advantages, but budget constraints. And as Steve said, if you're constrained to a single data center, don't put it in the same rack. Try to put it on opposite sides of the data center. Even if it's a small one.
At least opposite sides of the room.
Backup, restore, what is your backup restore strategy? I've had customers who back up their data. They do such a great job at it, but they never touch restoring it. We had one guy who decided, hey, let me delete this LUN on a Friday afternoon at 4:30, and I'm going on vacation next week, so okay. Let's go ahead and delete that and add that into my snapshot. Oops, I deleted the wrong LUN. Deleted about 5 terabytes worth of data, all user home directories for a hospital. It took them a week and a half to restore the data because they never really tested a full restore of their system. They had bugs with the flare code, had bugs with the switches, they had bugs with the backup device unit itself. So they kept running into issues that they had too much data that they were trying to restore in a small amount of time.
It's a major name we won't say, but it was horrible. And the funny thing is the guy went on vacation right after he did it. And he was on vacation the whole time. Stayed on vacation.
The guy on backup had to spend the next week and a half in very little sleep.
And I think the worst thing, Joe, is you may not know this, but he's recently been promoted.
There's the other side of it. When you're doing your backups, I had a company that was actually really religious about doing their testing of the restores. They were actually paying for their tapes to go off-site to Iron Mountain, and they were having a good time with that until the auditors came in and said, let's see what's coming from Iron Mountain. Every box comes back empty because all the tapes are still in the data center being practiced to do the restore. So there's the other side of the fact that you need to actually keep your stuff off-site as well, because if a disaster happens, you don't want it all sitting there. Yes, you're doing all the due diligence to test it, but still get it off site.
That kind of leads us into our next item is assess your staff. You know, are they capable of doing this? Want to expand on that, Hal? Well, I mean,
Why you being manhandled?
molested over there?
Do you feel violated?
Make sure your staff can actually handle all the technologies you're bringing in, or in storage case, they understand all the different aspects that they're going with. Do they need the slow storage? Do they understand that this is slow storage? Do they understand the connectivity methods? I mean, does your staff actually have the knowledge to be able to handle all of the different things that you're trying to do?
And that gets back to NAS, SAN, block, iSCSI versus fiber channel. All those design decisions have to take into account the people who have to maintain it.
Yeah. So next, in following that, you know, it's not just about redundancy on the storage, but what are you doing on redundancy on the services that are going to be consuming that storage? You know, a lot of the projects we have multiple web interface servers, multiple brokers, multiple, you know, SQL servers.
Mm-hmm.
You know, we've got multiple devices, but what people fail to understand is, oh, I got these multiple machines. Let me put them on this data store here because I have a lot of space for those virtual machines. So that leads us to, you know, a couple of examples of where we've had customers put things on multiple data stores on VMware, but then both of those map points came from the same aggregate on the NetApp.
Yeah, so
Right.
there's a number of concepts here we had a hard time explaining as concepts, so we just took examples that you'll go, oh yeah. So in the first one, you've got multiple infrastructures. They're load balanced, they're running an application, they're handling the high availability at the application level. You've got them separated, they're looking great, everything's performing, one goes down, the other one takes over, except ultimately, if you trace back the volumes and spindles, they're on the same volume because you had a lot of space for VMs, put our VMs here. Well, that's no good. You lose that storage volume. It doesn't matter that your app is HA, right? Bing, you got to start to think all the way down the stack. Where are the redundancies?
Between that and think, how am I separating my pools, my actual disk I'm aggregating in? How am I presenting the storage to the hypervisor? You know, those services should be set to be run on different.
And that's why you can't just say to the storage guy, give me this much, because it does matter where he puts it for these workloads. The next one is obvious VDI. You put a large workload of VDI machines pointing to volumes, maybe even separate volumes. You'll only limit them to 15 per volume, that's great. But those volumes rely on the same set of spindles. So they're contending for the IOPS throughout the whole process of operation. You may not know that based on the volume name you're given, the LUN you're given. You want to take 3?
Yeah, we just discussed 3. Number 4, pointing heavy workloads on the same volume. On the
Same idea.
Controllers and spindles
One of
as
my
important
favorite
read
ones
traffic.
One of my favorite ones that's actually not up here is we had a customer, or yeah, they were a customer, that was running their VDI, everything was running really slow. When you traced everything back, it was going through a single gig port on their storage. So I mean, there's a single point of failure right there.
Sadly, this was the same hospital chain, which will remain unnamed. They call this with VDI performance. This is, and I swear they're running hundreds of VMs, servers, everything, server and desktop.
They're using
And I started to ask them questions. Okay, here's what we got to ask. Where are the volume, blah, blah, blah. It went through 1 gig network port. iSCSI, NFS stuff, all going through the same thing. I'm like, really? I mean, can't you even just give me 2 gig ports? No, we can't. We're out of ports on the thing. That kind of like, it's like, what? These are real. We're not making these up.
Think about the workload and what's going to be consumed and try to match the technologies and configuration that best match that,
I'm glad you thought it.
that request. When we talk about building a big holistic system, it's kind of hard to do that. I mean, you can build different storage shelves and do some tiering and stuff like that, but this is where a point solution actually really comes into play here, because it now allows you that flexibility to be able to, maybe SSD is better, or maybe I could throw a data core server in there and leverage that RAM caching. Maybe if I'm doing persistent desktops, maybe Atlantis would be a good solution for that. And when you look at things, it's not just about bandwidth, but latency too. You know, where is that storage going to exist? Is it going to be on a storage array, or can I try to leverage the local host itself? You know, if I see people try to mount as many VMs on a host as they possibly can, try to resize the servers, squeeze as much memory as they can out of those servers, oversubscribe the boxes, and I'm like, why? You know, Windows likes to have a little bit of RAM for file caching and stuff like that. Just because it doesn't say it's being consumed doesn't mean it's not being used for a file cache. And if we can get it out of that VM first before ever having to hit any other storage device, we've got to win, right? You know, sometimes we can put in like a Fusion IO card into the box to accelerate things, SSD, storage appliance, like a data core is an example of a storage appliance, a high-end array. And then, you know, I didn't put a SATA one in here, but you can see when you get down to a disk, you've got 3,500 microseconds or 3.5 milliseconds latency just for the device itself. So we got to consider that our performance is going to be impacted by latency, not just by the amount of throughput that the device.
And I think what you're
can put.
seeing here is the really good minds in the field are working on this. You've got Atlantis, and you've got Tagile and Datacore and other companies who are leveraging these facts to accelerate performance and give you new features.
You know, and if you're expecting a certain amount of performance out of your system and you're consuming a certain amount of IOPS out of a system, and then you decide you want to start doing additional features like snapshotting, you need to account for the additional I/O that will be consumed. Some of these features like CDP and dedupe, they require additional operations in order to complete those tasks.
Move on.
CDP, you know, where you're placing the history file, where the data is on separate volumes. Especially with the CDP, some people try to put CDP on the same volume. I mean, what good does that do? Right. You just double the IOPS on required to write to that volume.
And you'd never do that for a SQL database, so you got to think about that.
You know, fragmentation can be a big deal. If you're in a NetApp world, everything's all fragmented, but if you're dealing with local disks and you want PVS write cache, you want that to be thick provisioned, and you want to try to avoid fragmentation as much as possible. Are those workloads going to do a lot of sequential reads, a lot of sequential writes, random writes? When you talk about something like an SSD, you know, one of the things we've been able to do is that previous slide of all the different types of storage that we latency and stuff, and we can leverage SSD, we can leverage a lot of the stuff and get an increase in how do you put read performance without, you know, a lot of additional penalties. But we've solved a lot of the read performance issues with various different solutions like Atlantis and stuff, but we still have yet to solve the write performance issue. And when we start looking at Fusion IO and SSD, yeah, we can write really fast to it, but we're also creating another problem that a lot of people don't really understand, and that each of those SSDs have a write endurance, and they can only be written to so many times before they burn out. And HP, you know, I decided to look up, what does HP do? So I look up, they have a couple different models. They've got one that it'll burn out in 7.5 months if you just constantly write to it. If you max that out, in 7.5 months, you have to keep replacing those SSDs. Okay, throw RAID in front of that. Well, that doesn't make any sense to me. RAID, high availability, but if you're dealing with write burnouts, if you start all these disks in the array at the same time, and one goes bad because at the end of the write endurance cycle, what's the chance of the other one being very close to the end of the write cycle too, right? So you got to really understand.
And when you fail one, you start stressing the others.
Are you really solving the problem by switching to Fusion IO, or are you willing to live with that problem? You know, some people need that type of performance, and they're willing to replace that server every 6 to 12 months. So are you willing to do that?
You can use a RAM-based SSD.
RAM-based SSD?
RAM-based SSD is great, but there's not many vendors that still do that. It's very expensive because the RAM is expensive. You don't have the write endurance issue. You'd have the same issues with any other, with the rest of the server with heat and aging of the.
Well,
device.
you had some feedback over here.
Yeah, I was going to say, you can look at the newer technologies for SSDs. I mean, Intel's high endurance MLC is pretty good. You can write pretty much a petabyte to their 200 gig drive before it dies.
How much you pay for it? I mean, you got the enterprise vendors like HP and Dell. They sell MLC-based SSD
Our
drives.
point really is though, make sure you know what you're wanting to do with the storage before you just go out and buy it.
Yeah.
Yeah.
If you're doing,
It's still gonna burn out, it just
Yeah.
take longer.
if you're gonna do a PBS write cache, I mean, do you wanna do nothing but writes to an SSD? You wanna use that for reading to really take advantage of the speed.
On the flip side, you know, SSD as far as reliability is actually outweigh mechanical drives now. So for general workloads, an SSD might actually be better than a mechanical drive because its mean time between failures is lower, higher I should say. Latency is lower, heat's lower, power consumption is lower, noise levels lower, not subject to vibration issues. There's a lot of advantages to using SSD.
Well, there's also better approaches, like we're talking about at Atlantis, for example, inline
But if
deduping.
you're doing something like the virtual desktop where you're redirecting the write cache, 90% of the writes, 90% of the traffic to the write cache is writes. That's why it's called write cache.
Right.
Right? Very rarely you're going to reread.
All right, so
All right, let's continue on.
you're up with this one, right?
We covered this a little bit in the first session about evaluating, benchmarking, and stuff like that. Is we go in and somebody says, we try to figure out, how many IOPS are we going to need for a desktop or Zen app or whatever, and nobody really knows what the users consume. The data is out there. We just need to go out and collect the data and analyze it. If we're going to move users from a desktop to VDI, why can't we capture what they're doing now and extrapolate from that? It's not perfect, but it's better than trying to guess. And if you guess, you could either underguess or overestimate what your actual requirements are. And then once you get the solution in and you start building a VDI environment, why can't you measure it then? Why can't you have a pilot of test users and measure what kind of IOPS are really required, and then go out and buy your storage and design the storage around that? Once you get the storage in there, make sure the storage is providing the IOPS that you require.
Which brings us beautifully to the lies of storage vendors. And Hal contributed the first point, as the first lie of vendors occurs when...
I'll make an exception though, because, Tim back there, he doesn't lie. He actually tells it like it is.
And Jim,
And Jim back there
yeah.
too, so.
But in
It's a
general,
We're not
sales
talking about
sales
anyone
guy
who's
that-
exhibiting here. What's that? Right, okay.
in general, we find that when a storage vendor opens their mouth, it's not exactly the truth coming out.
Let's say a hardware storage
Okay,
vendor.
hardware storage vendor. You
No,
need
but
to
that
find the
leaves
biggest
out
frame
TJ.
To take care of everything. It'll handle all your IOPS, it'll handle all your capacity. You'll never run into issues.
All right, what's an IOP? Input-output operation per second. Hopefully you guys have a little bit of understanding what IOPS already are. If not, let you finish reading the slide. Generally, we like to measure it in terms of sequential reads, meaning to be able to read multiple blocks sequentially and not have to skip over into other areas of the disk to get it. Random reads, skipping over the other, heads having to move back and forth to grab different blocks and to reassemble them. Sequential writes and random writes. So some of the tools we like to use are iometer or iometer. SQL IO is another popular one. I like to try to take benchmarks of all four of those metrics I just mentioned: sequential read, sequential write, random reads and random writes. So, and then I also take measurements of different block sizes and stuff like that, see which of those actually be optimal. Here's an example I had from last year, and with random reads, you got to understand how to interpret IOPS because not all IOPS are the same. In this example, we have a block size of 64K, and SQL IO comes back and say, oh, you're getting 28,000 IOPS. Sounds great. Okay, bump that down to 32K. We're getting 53,000 IOPS relative to 64, so we're getting a 90% increase in the number of IOPS by dropping down to 32K. But is that really true? Is 32K the winner? In this case, no. IOPS are based on measurement of the number of transactions that you can do at a certain block size. So really what we want to measure is the throughput. And so if we reanalyze this, if we take these numbers again, we'll get 1,700 megabytes per second relative to 1,600. So we can see that 64K block size is actually going to be better than 32.
You kind of blew through the lies of storage vendors, but this is one of the things a lot of storage vendors do is take an optimal block size and read scenario and talk about we have 200,000 IOPS, but that's not what you're going to get when you do your workload.
Yeah.
Right?
And in this case, we've already exceeded the theoretical max, so, our benchmarks were really no good to begin with. We need to figure out, well, why did we get that? Did we have some kind of caching appliance in between there that actually helped accelerate the writes? We want to be able to measure every step of the way, not just the host to the storage. We want to say if we put data core in there, we want to host to the controllers, from the controllers to the actual disks themselves, right? The storage that we're aggregating in. Because we might accelerate really good over here, but we could have potentially oversubscribed on the back-end storage. So we want to be able to know when we're reaching a theoretical max on the back-end storage so that when we're getting these great numbers in front, we're not oversubscribing.
So hit that number for me for clarity. It's telling you 1767 megabytes per second, but you're running over 2 8 gig HBAs, so
Correct.
It can't be.
Why not? Again, bidirectional, but we're only going one way for the traffic.
Right, but this is running read.
I don't know, I'm asking.
Sure. Well, when you think of an 8 gig HBA can do what? What would you say in the last slide? 400 megs per
we were
second?
saying 800.
I was saying 800, you're saying 400.
That was the 4 gig.
I'm counting traffic going both ways.
Okay,
When we're doing a test, we're reading, right? We're not reading and writing
okay,
at the same time.
okay.
So we're only in one direction, not by.
I think we're going to get into this debate again, right?
We're doing a read going this way or write going back to the
Okay,
storage device, right? So you go back to what can the single direction go? 400 megs per second, right?
okay.
So I don't know. You want to? I don't know. You.
Go ahead.
Here, use this.
It's all. I want to skip this slide. Let's go to IOPS. Here's something I actually pulled off a wiki. So some of the data actually might be old. You can, they got PCI Express cards that say they do 1 million IOPS at 4K. Actually, no, it's not 1 million IOPS at 4K.
I have no
It's 1
control.
million IOPS at
Trying to help
512
them not get
bytes.
attacked.
So keep that in mind. What block size are they using? When we look at Fusion IO, they're claiming 1 million, 2 million IOPS, but when you look at it, it's 512 bytes is the block size. So everything's relative. And as well, we talked about some of the lies of the storage vendors. If you use your storage, you can lose it.
Question?
On the previous slide, you mentioned, say the hard drive at, say 10,000 RPM. If you have a NAS unit with multiple SATAs, do you
Right.
just multiply the IOPS by the number of disks in that drive to
He's asking if you have multiple disks in an array, do you just multiply that number? Is it linear or is
Yes.
there some other calculation?
And that's how you add additional bandwidth into your that's why we build these large storage arrays here. Let me go through this next section here and I'll.
Hold on. Right, there's a RAID penalty, there's cache involved.
Also, you could have
Well,
an
not-
expander penalty, so
But
Right.
that's a whole different discussion though.
like being on the same expander
Well,
as others.
that's why
Right.
we're here, is to have this whole discussion, so.
But all things being equal, we're not changing the RAID configuration when we're adding more spindles.
Well, I think what we
It's
can
grade
say,
5 and grade
what we
5.
can say though is if one drive has this many IOPS possible, then it will be it'll be linear. Then 2 has twice as many, 3 has 3 times. But there are impacts for RAID and controllers and other factors that may take away
all
from that.
things, all things being
Or it could add
equal.
to it with cache and other acceleration.
It goes back to some of these lies that the storage vendors some of the things they just neglect to tell you. If you use it, you lose it. When you start getting to 50, 60% capacity of your storage array, performance is going to take a nosedive. And one of the reasons is...
Can I ask a question about, I'm curious, does everybody know that? Because we found it out the hard way, that a traditional arbitrated loop SAN, like an EMC, IBM, others, that they do not perform the same above, it's some number, 40, 50, 60%. Is that generally something you all know? Just curious.
That was like that back in the early 90s with the hard drive
still like that.
Yeah. Yeah.
Jim, what would you
Jim.
like to say?
So I found in this case that a lot of performance drop down to disk controllers.
You say it comes down to disk controllers.
Well, that's a bottleneck too, but that's a different bottleneck. But when we start looking at a mechanical disk, in order to get the advertised IOPS, the data is placed on the outer edge of the disk. And you can see there's a lot more space on the outer edge of the disk than as you start going in, you got less surface area. So that means less data can be read in one spin or one cycle. So you have two types of latency. You have your rotational latency, which is about 2 microseconds, 15K for the disk to spin around, right? And then you also have your actuator, your seek latency. And if the head has to move from here to here,
We keep doing
there's
that.
additional latency involved
Yeah.
to move the head, the time it requires the head actuator to move, right? And as we start moving in, we're able to read less data, and it takes longer to move the head back over to that area of the disk. Therefore, our performance actually dropped because of that. So what vendors did to get around that was...
Hold on, Joe. Hold on. We got some feedback. What was that?
The speed's also faster on the outside.
The speed's faster, right? Because it spins at a faster rate. I want to address something else before you go into the next point, to Jim's point, because one of the things that we've seen that is controller-based, and your early example had huge racks of disk with a couple of controllers, right? In traditional technology, it's an arbitrated loop. The fiber channel loop that's servicing those drives has to wait for drives to get, be able to talk on the line. And they don't scale very well. A lot of the new vendors are kind of making it more, where they're putting the controller closer to the disk and having a finite set of disk per controller, so you tend to get more linear scale. Yeah. There's other optimizations inside the firmware of the drive, like XIO, for example, but the concept that Jim came up is key. The old SANs want to have a big, giant arbitrated loop and shove as many spindles in there as they can, but they have contention for the controller.
And then what they did was they just threw more disk to try to get more bandwidth. And part of throwing more disks in there, they actually did what's known as short stroking. And that basically put the data on the outer edge of the disk and throw away everything else. The data in the middle, not even visible to the controller, so it's not even, it can't be allocated. So, to get that bandwidth, we would add more disks to add bandwidth and try to get around that issue of latency by adding more disk but using less storage per disk.
And again, that's where I think some of the newer people in this space are doing very intelligent things, like we keep saying the same names, but Atlantis, for example, it's not really about the raw spindles. It's doing something smart in software about how you cache, read, dedupe, and so forth.
All right, let's talk a little about measuring IOPS. The two tools really, they're pretty much old, so that you can see the cons on both are going to be old, as they haven't really been updated in a while. A lot of people like iometer, because you can actually do mixed workloads. You can say 75% reads versus 25% writes. With SQL.io, you can't do that. SQL.io, you could just command line based. You just run it, get your output, dump it to your disk. Iometer is more GUI based. You can pipe the result to a disk, but it's a little harder to work with. I don't want to get into a big discussion of which one to use, but if you're going to use a tool, you need to be cautious of the different types of things that can get in the way of doing this. If you have a caching engine in there, is that going to affect the performance? Are you trying to measure disk, or are you trying to measure against the cache? Inline deduping, how is that going to affect performance? Do you have write back set or write through on your controllers or down to the disks? One of the things I ran into, and I'll show you here in a second, is something like SQL.io decided it likes to write blocks of zeros.
How are we doing?
Right?
I think we're good.
And so when I run this test, it's sitting there trying to write blocks and blocks of zeros, and the storage controller says, oh, hey, I already written zeros all over the disks. Let me just go ahead and just allocate that storage. I don't actually physically write it.
So you're getting magical speeds because it doesn't actually rewrite that same data.
Because the storage controller is basically just throwing out that packet saying, yeah, I already know how to deal with it. Inline dedupe, if it already sees, oh, I already see that block. why do I need to rewrite that to the disk, right? You know, I'm not measuring against the cache, I'm trying to measure against the actual spindles that are backing up the cache, because I want to be able to know what the measurements are for both those things, right? With and without the cache. Run your test for a long time. Again, you know, everything got some kind of cache in there. When you get down, we use a lot of XIO, it's got cache on there. Can I disable it? Maybe. If not, run a long enough test so that you overload the cache, right? So now you start having to get down to the spindles and not rely so much on that cache. Run the test multiple times, especially if you're trying to do this in a production environment off hours. I would recommend you do it before you ever put any data on it, because you never know what else is going to be affecting performance of that array. We talked about that. Disable things like snapshot CDP. If you want the test to include that, then go ahead and include that, but do it in a very controlled environment. Test with the cache on and off. Test the front-end application servers. You can do Exchange or SQL. Test that, right? And then test to the actual disks. Have some kind of expectation of what the numbers are. If it's, say, I'm going to get 3,000 IOPS out of this thing, are you really getting 3,000 IOPS out of it? And if you come back with 6,000 IOPS, you got to scratch your head and say, where are those other 3,000 IOPS that I was expecting coming from? Maybe I got the math wrong, or maybe something configured is not configured correctly, or maybe I forgot to turn something off.
Jim?
So there's a kind of a cool thing you can do with IOPS with the differential that you're talking about, because you can measure where you think the bottleneck is going to be, whether that's going to be.
Jim, we'll just have you speak into a mic because he can't hear it without it.
We got an accent too. It's like,
Yeah.
don't worry, I love Jim.
Excellent. So basically, if you're using IOPS or any other kind of tool like that, if you get where you expect your bottleneck to be, either on the controllers or the disks, is that better?
Yep.
Yeah, here we go. Either on the controllers or the disks, you can actually find other bottlenecks in your system, because if you're getting way under what you think you're going to get, it means that you've probably got a dodgy switch or something else in the middle. So that differential that you're talking about there, Joe, is really important, because it can help you troubleshoot your whole length of all the lanes back from your VM back to your storage at the back end.
Yeah, great point. You know, Jim, I think you deserve a book for that.
And I have no idea what he said, by the way.
Joe?
And there are a couple more books, so if people speak up, they can get a book.
And I still didn't understand what he said.
He was validating what you were saying.
Okay. I like to use SQL.io. I've used Iometer, and it's sometimes a pain in the ass, so I just get SQL.io, and I...
Joe?
I really think you have to be careful.
Give him the mic. We have enough time because it's actually 10 after. When it's over, there's 20
I think it's
minutes.
very important. I mean,
Unless
SQL.io
I'm doing
is
that
great,
wrong,
but
right?
it's a file-based tool. It's not a block-based level tool of I/O. So based on underlying things in the operating system, you got to realize, you look at here, SQL.io is creating a file here, it's going through the file system, which means that all this I/O you're testing is actually going through all the filter drivers in Windows. So if you have a poor filter driver, your I/O results here can be skewed. What you really want to look at with I/O, you have to be really careful when you start measuring I/O, because there's a difference between the I/O that you're doing here, which is actually what we call perceived I/O, which is what we see, and what's actually going on. This just tells you what your I/O is for your given configuration, but it doesn't tell you what the problem actually is. Another good tool that you may want to mention using is Expert, but you're going to run into the same problem. It's actually going to give you your I/O times, so you can see how long an I/O took. You can also put I/O meter and test a raw disk and bypass some of the filter drivers as well. So that's just what I want to point out. That all these tests here are done using file-based.
Yeah, it's a good point.
Block sizes. Anytime you go on a file-based, you run into block size applications
Right.
and so forth.
Yeah, great feedback. Thank you, Michael.
So I would have just...
After he speaks, I'll get a time check.
If you're measuring from a Zendesk VM, and you're using PBS to produce that VM, you have a file level filter driver in, and that's going to be your bottleneck. So you run Iometer or SQL.io on there, you're going to run into an artificial bottleneck in the VM, and you're going to need to do multiple VMs to ramp up the amount of IO.
Right, to simulate the actual
DVD
condition.
is the same as well.
Right.
And you'll find that, as Mike said, lots of other file level filter drivers. If you you're going to test, use a vanilla VM. Yeah? Just do next, next, next. Make sure you haven't got anything funny going on, and you'll get a much better result for all these
Yeah.
contests.
Hey, how are we on time? I'm confused about the start time. Do we, how much?
I also have one question.
Okay.
That's, you said that you should have a general idea of what IOPS you should expect. How do you get that number?
That's what we do. We start off with a baseline, and it may not be perfect. It may not be the scale. You got to start with a baseline. So when you start measuring and you start scaling out, you actually have something you can compare to, and you can see, hey, as I'm scaling, am I introducing more latency, and is that costing me additional?
In the interest of time, Joe, take us through your example with the data.
Well, I mean, there can be some raw number calculations based upon your rate penalties, your
Right.
expected ratio.
Yeah, you can estimate.
How you're grading them.
And
Yeah.
then we go back to storage.
It's open. It's right back there. You got to move it to the screen, though. I didn't think about that.
There's some generally accepted rules as far as
Keep going. Keep going. Keep going. Keep going.
your raw disk speed on the back end, right?
Keep going.
You should have given us 2 monitors.
Yeah, no.
So I got a comment, working at a storage vendor specifically.
All right. That's probably good.
If the vendor offers a benchmark that runs on the SAN, as a plugin, I don't care, as a command line utility, don't use it. Because when you're benchmarking on the SAN, you're getting rid of all your, let's say,
Yeah,
overheads,
right.
system
The real world penalty of
It's
communicating.
not
Yeah.
realistic. It's something that sales use, they like it because it gives them better IOPS, but it sucks.
Which
It's
goes
not
back
really
to,
usable
again,
website.
vendors'
Yep.
time.
Okay, in the interest of time, let Joe take us through this example. This example is very illustrative of the impact of some of the things we're talking about.
You did the wrong. There we go. One of my customers, we decided we wanted to test everything out. So I ran a bunch of SQL IO commands, gathered all the, piped it to a text file, and actually transposed it into
Are you seeing what you need?
the spreadsheet you see here. And
Maybe
when
I
I
should
looked at
shrink
it,
it.
I'm like,
Yeah, let me,
you're not helping.
no, I know. Let me make it so you can read it. How about that? Is that too low?
They can't see that
That's an eye
either.
chart.
Let's try this.
All right. We got some interesting results,
That's
and I ran it a couple of times, and when I looked at it, I said,
But you're
wow,
not
I'm
seeing
getting
this. Do you
really
need these
good
columns?
throughput here. Really good numbers of IOPS, not much difference between RAID 10 and RAID 5. I'm like, something's not right here. Again, going back to our expectations. Quit messing with it.
Do you need to see the left-hand side?
I don't care.
Okay.
So I did a little
Yes, sir.
investigation,
Technical
and
difficulty between
what I
keywords
ended up finding out, and I just kept it for reference purpose, but up in the upper left-hand corner where it says RAID 1 and RAID 5, and then up there the VDIS size is 110 gigs. So I created a 110 gig volume, a test file. Actually, I created a 110 gig volume, put a 100 gig test file on it, and ran the test. And what happened was, at the end of the test run, I only had 640 megs allocated on the storage controller. So how is that? If I created a file that was 100 gigs, why is it only 640 megs? I mentioned it before. It's because SQL IO was writing all zeros, and it just threw it out. So when it created a test file, it zeroed it out.
It
The
was in
storage
write
controller
cache.
saw that, and it's like, I don't need to write this. I'll just create a meta tag for it and send a result back. And so at the end of all the tests, only 640 megs was actually allocated out of the 100 gigs. Second mistake. When I ran this, I created the test file. The test file was actually in the RAM cache. So if I'm going to write a test file, the storage controller is like, hey, let me just keep a copy of that in memory in case you want it again. So if I'm going to write something and read it, it's already coming out of the cache. So I'm not even testing the spindles at this point. So that's why I'm getting great numbers, because I wrote a thin provision test file to cache. So again, so I reran the test, and if I can get over to here, we got more realistic numbers on writes and stuff. So
Hold on, we got some feedback.
It's actually a legitimate test because it shows you what your fabric is capable of. It shows you what your control
Okay.
What?
It's legitimate because it shows what your infrastructure can do, your network and your connectivity.
Yes. It is, but you just have to understand the context of what you're trying to test. If I'm trying to test what the XIO box can actually do, not necessarily what the data
Right.
core can do, they're two different things.
And it is an artificial test. It doesn't simulate a real world scenario.
And there's no
You got a
real
mic
data
coming.
being written either.
You got a mic coming, Michael.
But you're not. This is, I have to disagree, sir. I respectfully disagree. These tests are, these again are practical tests. What you're saying is this is the perceived test.
Correct.
This is not telling you what's
It's a
actually
sanity
going on.
check. It's,
The only way to actually tell what's going on is to start at the bottom of the layer and work your way up the stack. Otherwise, these numbers here, I mean, you're not getting the operating system cache if you turn off the operating system cache.
that is correct.
Again, these are for silver cache on a file system. So things like block sizes, NTFS, I have no idea. You could run this same test on 3 VM and get completely different results. So your only true way to get real numbers would be to test raw.
Yeah. In this case, I did this on the controller itself, so I was testing the
Now, you
actual
tested
controller
this
and
on a Windows operating system running SQLIO.
the what? Yeah, it is Windows.
This is SQLIO, correct?
Correct.
Which is running on a Windows box.
Correct.
Which is running through the file system and the filter drivers and the operating system.
No, it doesn't go to the file
crashing
system.
Windows and-
Doesn't
and
go
all
to the
that
file
stuff.
system. It's, Tim, can you explain how data core works? It doesn't go to the file system. It's actually a raw device.
SQLIO, you created an equal, I saw it, it's equal.txt.
Yeah,
That was a file that lives on an NTFS file system.
yeah, you do. I guess you do have to
So you're
format that.
going through the filter drivers, you're going through the OS stack. The real way is to eliminate that stack and go at a higher level than the raw. To get true results. These are perceived.
But that's also going to a block level, so it's a different test. It's a reflection of a different parameter.
64K NTFS
Right.
volume versus a 4K, your results could change.
Right.
You're going through the Windows cache. Windows is
Right.
going to start caching itself, just like the standard cache. So these results, this is what I call file.
I understand, but isn't this a reasonable simulation of what a Windows-based application can do? I mean, because those are going to have the same constraints.
Or a Windows application you can do on that host.
Right. Well, fair enough. Yeah. Agreed. Yeah, agreed.
Yeah, if you're doing a hypervisor, you'd want to do the test from the hypervisor layer.
What was that?
I said the best benchmark is DD on the roll line. Just write a shell script that will simulate your patterns. Make sure that it pulls from a file that's completely random. So
Right.
recreate something from dev random.
Okay.
And
Yeah.
in our defense, we are Windows guys trying to run
You can
storage
use-
as
you
we're
can
going,
use
so.
DD inside Sigwin if you want. It works. I got 1.6 gigabytes on my laptop.
How much time we got?
When I was walking up, it was 10 minutes
10 minutes?
when I was walking back to gym.
Okay. And how much time do we have left? 7 minutes? Okay, good. Anything else you want to cover, Joe?
Well, we had a whole sizing section. I guess we're not getting to that.
Guess that's not happening.
Why don't we just open it up for questions?
Or, yeah,
Just
discussion. There's
talk
been some
about
great feedback. Yes?
Pros and cons for SSD versus flash or RAM. And just curious.
He's asking pros and cons.
I mean, the caching technologies are evolving, right? So people are trying to cache on SSD and they're trying to cache on RAM, and there are vendors who are trying to do both. Just wondering about pros and cons.
Yeah, that was a section where we won't get to the section, but he's asking about the pros and cons of, caching RAM, SSD differences.
I mean, the price of SSDs and RAMs, they're both falling sharply.
Right.
I mean, I don't know how linear relationship they're falling, what pace they're falling at, but eventually I think I prefer RAM personally because of the
Right.
faster and it's price.
Right.
Eventually the price will be down.
I agree. I think the bottom line is if you can fit it into RAM and you can afford it, you should do it, right?
The prices for servers
Yeah.
are coming out like even 512 GB RAM.
It's huge.
Affordable, but the prices
Yeah.
look like 4 years back you can't even get a server for 512
Right.
GB RAM.
Well, that's why I personally like the DataCore product, because they're doing a block level SAN where they're leveraging the entire RAM image of, it's a Windows server, but it performs great. And to that point, as the price drops, you can always put more in and use more. So, I'm a huge fan. I think anything that's doing software, RAM, and then to whatever degree SSD is always going to have a performance edge. But then you still have the price
Right, but
impact.
what are some of the pros and cons in the field? Have you looked in some of those things? I'm just curious.
He's asking about pros and cons of those differences. I'm not sure what you mean by
For
that.
example, like, if you had a choice in a customer environment, and
Well, just talking practical terms, because I do architect my customer solutions, we would use them all in the level they could afford. So we're advocating data core because we use it and it's successful. We would put the maximum RAM that's practical for that server, and we would also use their tiering feature for SSD for workloads that require that. So you kind of choose, and you just carve it up based on the workload. If it's an archival backup, you don't need that. So you may pass through the RAM for caching, but you just put it off on some SATA disk.
Which goes back to my hot topic, which is you choose what you need for that specific workload.
Right. That's pretty much what you do. But we're not talking a massive premium, because it's still, when you take like a software-based product like DataCore, the whole system cost, the full end system cost with SSD and RAM, is still going to be way less than a major tier SAN vendor. So I don't think you're trading off that.
Asking which one is actually better is like saying I want to buy one big SAN for everything. Again, SSD is going to be better for this scenario. Slow-moving storage is going to be good for this scenario. RAM's going to be really good for this scenario. It's not necessarily the same thing.
You know,
I think my question was, in which scenarios would you choose SSDs versus that?
Yeah, that's a good question. Which scenarios would you put an SSD tier in, for example?
Well, when the working set size is not practical to cache in RAM, when it's, let's say, over 112 gigs.
Yeah, I think maybe the size of the working set is good. I'm sure the characteristics of the workload. He was suggesting the size of the workload. If it's just inherently larger than the RAM image, maybe your RAM is 96 gig. If the workload is 325 gig, then you may want to have an SSD layer that can handle that much.
We have an SSD layer for our electronic medical record system because we just couldn't keep up. We think we're on over 1,000 spindles. We put in an SSD layer to handle reducing transaction time now down to about a millisecond.
What's the software layer that manages that? TMC. How much SSD did you put it in that case?
I didn't actually manage that project.
Okay.
So it was a considerable size SSD.
Like a
Contribution, but I mean, it's easily business justified with the reduction of transaction time.
Sure.
1 millisecond transaction time, those are stable transaction times.
Right.
I guess in terms of VDI, it also depends on persistent versus non-persistent. I mean, for an RAM side.
Exactly. Right. So in that regard, would you put PVS on an SSD
why
tier?
do you put PVS on?
Well, I'm just asking, would you do that? Would you put a write cache on SSD, just as one example?
Do you need it? I mean, if you put a local spinning disk in there, is that fast enough? You're localizing it?
No, but I mean just the writes. So, even if you have writes, you can still write as
No, there are other solutions. I mean,
Hold
Jim
on
back there
one
has
second.
the,
Another question coming this way. Yeah, take the mic real quick.
while come back there, I probably, like, again, going back to the Atlantis solution, I probably would end up doing something like Atlantis before I did SSDs.
Yeah.
All
Yeah.
right, we got another question over here, guys. Hold on.
Okay, I'm hearing that link clones by nature are misaligned. Do you have any comments on that?
Linked clones by nature are misaligned.
You know what? We do Zen Desktop. We don't do VMware.
And we have Jim over here asking, tighten up the top.
Yeah, Jim can take that one.
Couldn't tell you.
So link clones are based on really local technology, which, as you say, are misaligned by, not by design, but by accident. But yeah, you're absolutely right, they are misaligned. Okay.
Same with Citrix?
No, Citrix PBS and FTS is completely different technology than the View Composer, so no, it doesn't have the same issue.
Quality is different than the
Sorry?
Microsoft or the VM.
Yes, because link clones aren't the same as MCS at all. It's two completely different technologies.
Well, I know PBS is different, but the...
No, link clones and machine creation services are different from each other as well.
Very good.
But Jim, why is that? Because the common blocks are somehow out of sync with the, I don't see why that would be misaligned.
It's all to do with the reader logs. I mean, we actually had proper trouble with reader logs because where they start their misaligned, we actually had to put in specific optimizations in
Okay.
to cope with link clones and reader log technology.
Okay.
If you really, really want to know exactly why it's weird, ask Shane.
Okay. Any other comments or questions? We appreciate all your feedback. It's been great. and thank you for coming.